The objective of this video is to describe the purpose behind an exception handler and use examples. So the first hit I see on Bing when I search for this is an exception handler is code that stipulates what a program will do when an anomalous event disrupts the normal flow of that program's instructions. So anomalous, that is deviating from what you expected to happen, that will need to be taken care of. And the thing that takes care of it is an exception handler. So there are a few forms these exception handlers can take. The first is by whatever specialized programming language construct exists for exception handlers. And when I say programming construct, my first go-to example is always this built-in thing that languages have, like print. So when you print, you're using a construct, and by typing those words out, P-R-I-N-T, the language knows exactly what you're expecting, and so then the output shows up on your screen. So there are language constructs for exception handlers. There are exceptions in computer hardware as well, and their example is interrupts, or in operating system IPC, which is inter-process communication. Don't worry too much about that though. A picture's worth 1,000 words, and I'll just show you like the signal that something like an Arduino board can give you. So to summarize what we've learned so far, an exception handler allows a program to respond gracefully if it encounters an error, as opposed to just crashing. Now let's break the semantics down a little bit more. What is the difference between an exception and an exception handler? Usually, an exception breaks the normal flow of execution, and then it executes this pre-registered exception handler. The details of how this is done depends on whether, again, we're talking about hardware or software, and also how that exception is implemented in either that hardware or software. And this is a possibility too that some exceptions, especially hardware ones, may be handled so gracefully that execution can resume where it was interrupted, so actually nothing stops at all. And let's use some real examples here, a software one to start with. So let's say we have this function or method of divide. And for parameters, we'll take in A and then we'll take in B. So now the code says try this block, and a variable, a float by the way, which is ironic and you'll see why at the end of the video, but a float type of variable called result will first initialize as a 0, but then it's going to get whatever A divided by B is inside of it. Once that happens, go ahead and print this to the console or your computer screen. You're going to print what that result is. Now here's the exception handler. The code says catch divide by 0 exception. So if the person puts in a 0 here and you try to divide whatever A is by 0, then there's going to be this problem, and on the console it's going to say the divisor should not be 0, like you can't do that. Now that's just one example, divide by 0. That's a very popular example too, an exception that you definitely want to catch. And you can see you can have something like finally, where no matter what happens, the console will print, this message will always print. And I could show you an even simpler example. So here we have a class called connect, and then there's going to be stuff here. It says try code to connect to server, but there could be an exception if the server is down. And whatever the programmer writes right around here is what will happen. Maybe it just tells us, there's an error. So the code examples is pretty straightforward, and I do find the verbiage pretty funny. You'll see words like thrown put into these exceptions, like throw this error. Some errors are big, but most of them are really small, and just by saying thrown, it's like creating an intensity to it that I don't know is so necessary. Here's another example of that. Maybe you write your own method and you want to check if the arguments make sense. So for example, you have an image and you check that the width is less than 1, which we would say is a bad thing. So if that happens, then we could type into our code here, we could type use an illegal argument exception. But how funny is that it is illegal? I put here that not always, there's not always a need for panic. Exceptions may occur when you do something like try to read a file, but you might not have access to the file, or that file doesn't exist. That's a pretty tiny error. You could try to convert a string to an integer, but maybe the string is ABC. Clearly ABC is not a number, so sure, that's a little problem as well. My last example is maybe you try to connect to a database, but the database is just currently down at that moment, or there's just no network connection. So there you go, just some smaller problems. But don't get me wrong, when we're talking about exception handlers, there's just lots of choices. I don't want to make this intro video any more complex than necessary, but I thought I'd give you a little sense of all the different types of exceptions that might exist. Now here's our hardware example using the Arduino chip kit. You have actually a little light bulb, a little LED here that will light up if, for example, there's an illegal address exception. This term is an interesting one to me, trap, which basically means a divide by zero exception, so that might happen. And apparently there's other trap type of exceptions, but in either case, the LED number 5 will light up there. So if your code is trying to do something that is impossible, the hardware can tell you visually, but also the output from the code using these exception bits can give you some insight into what error you're looking at, what problem it is. For those following along on my Intel manual series, this arithmetic overflow exception will look familiar. There's our trap one right there, so if that was to happen, we would get a hexadecimal value of D shown, which people who know hexadecimal know that's just there's a binary equivalent that you should kind of maybe see when you see those hexadecimals. If you don't know what I'm talking about here, you can go to some of my earlier videos where I really break that down, but for the sake of this video, that's pretty much it. I thought I'd give you just a little peek here at some complexity. Remember, this video was inspired by my series on the Intel manual, and the reason I'm making this is because we're at the exceptions part while reading about floating points and all these different types of situations that can occur when working with floating points. Even something as simple as the computer realizes that there's this loss of precision going on. And it also talks about underflow. Most of you are probably familiar with overflow, or at least you've heard of it before, but there's also an underflow situation that can occur, which is really similar, maybe not surprisingly, to an overflow situation. And here's something I didn't mention yet, but if you try to write to an illegal address, like that address doesn't exist, or maybe it's locked or something, there can be an exception from that as well. And one last thing, it's just interesting that the first body paragraph of this Wikipedia entry for exception handling, it immediately started talking about the IEEE 754 standard for floating points, which again inspired this video to begin with. Now don't worry, I'll never turn on ads unless I'm really desperate, but I just thought I'd see if I could get some coffee out of this fun work I've been doing. But no worries if not. Thank you for watching.